Okay, so by the time recording begins, let me first initiate some discussion. So dynamic programming is not new to you. So all the participants in this session, you all were introduced to algorithms. Specifically, I mean design and analysis of algorithms, and you might have had a subsequent amount of lectures on dynamic programming. So before I start this session, uh, what exactly is dynamic programming? And as a student who have been already introduced with dynamic programming, and you might have already attempted few problems in dynamic programming, so you are not completely new to this algorithms, writing code, and writing dynamic programming solutions. So what I want is, before I begin the presentation, just to make sure the agenda sets with what you are expecting, uh, what exactly is dynamic programming in your language? Or you might directly reply in a chat, like what you are exactly expecting in dynamic programming. What do you want to know in that? You might be knowing something already. So what additional you want to know regarding dynamic programming? Yeah, in this session, as and when need arises, we will also discuss what exactly is greedy method and how greedy method differs from dynamic programming. But from my side, I would like to keep it more towards dynamic programming. Greedy method and other methods we will look into we will look into them in the coming lectures. So yeah, you can reply in the chat window. What I am expecting from you is, what are your expectations from this session? Specifically, this session on greedy and dynamic. You might be having some questions, or you might be interested to know some theoretical aspect or practical aspect. Whatever it is, let me know. Because remember one thing, this is not a theory session, neither any marks are associated. This is purely something I see it as a value addition, and I want you to see this as a value addition. So be interactive. Yeah, so can I get few replies in this? What you are expecting from this session, or what are your main expectations you want, or you want me to engage in this lecture? I think Rakesh says hands-on coding on DP, hands-on coding on common DP program. Okay. Approach plus method. Okay. And others? So only 3 students from entire 108 students. Rest they just want here to be the difference between top down and bottom up. Okay. How to first come up with recursive method and then convert it into dynamic programming. Okay. Mm-hmm. Okay. Okay. So what is the main difficulty you face? Like come up with a brute force logic, then converting into more optimized solution. Okay. Okay, so what we will do is, we will keep this session more hands-on oriented. I think Samyak has a question. What he says, many times we know that a question can be solved, but converting code is hard. So they are forced to do that, especially in top-down approach. Okay. How to identify given problem in GPM step-by-step approach to solve problem using. Okay. Okay, so yeah, I got a fair bit of idea about what are your expectations. So yeah, so we will discuss in a similar fashion based on your expectations. So in here, what we will do is, we will in this session we will see what exactly the dynamic programming that you all know, that what exactly. The first and most important thing here is to how to identify if the given problem is a dynamic programming. Does it require dynamic programming or not? That's the first step to know. So only when we know that if this problem requires dynamic programming, then you can spend time on working on that. So let us see what exactly is the dynamic programming and what is its steps. And if time permits, in today's session, we'll try to solve one basic, very simple dynamic programming problem on HackerRF. I have deliberately chosen that problem so that you can understand how we can solve that problem by what are the steps which we are going to see in this session. Okay, so and before we start, I hope I need not tell you what is the importance of dynamic programming. Remember, most of the modern day systems, which includes your AI methods, your airplane routing algorithm. Remember, this is one of the most used programming methods in current computing industry. Yeah, we do have some parallel computing, parallel algorithms and that, but still this is the fundamental, and many real world applications are based on dynamic programming approach. It doesn't mean that other algorithm design methods are not used or not. Everything is used with equal importance, but when it comes to real world expectation, most of real world problems, they in turn or somehow end up being solved optimally by using dynamic programming. And if you, I think most of you are already aware that if you want to appear for big companies, like especially we call it as FANG, like Facebook, Apple, Netflix, Google, and Microsoft, big product development companies. In those companies' interview, they always check how good you are in dynamic programming, how good you are in greedy, how good you are in data structures. So that also comes into picture. So this is something which always propels you or puts you into higher package roles and always opens up the window for product development companies. See, no matter at what stage in your career you switch to product based companies, those companies will always ask you questions on dynamic programming, greedy, and algorithm design. So this is something which, as long as you are in IT industry, you will never forget this. So you will always require these algorithms and data structures. Like as I always say that a civil engineer always needs to know surveying, structural engineering principle. Likewise, a CS engineer always requires the knowledge of algorithms and data structures. Okay, so let us move to one by one. So what is dynamic programming? Remember, it is basically a method for solving optimization problems. Now, when a question arises, how do I know that if given problem is a dynamic programming or a greedy method? Remember, any problem which asks you to find out solution like minimum number of steps or maximum profit, minimum path, minimum profit, max loss, or max profit, minimum loss. In whichever problem you find min and max, which asks you to minimize the output or maximize the output based on few constraints, 90% chances such problem is always a dynamic programming problem. I mean, 90% that problem either has a solution using a greedy method or a dynamic programming. And specifically when talking about competitive programming, like when you are appearing for competitive programming events, most often you can always consider that approach as dynamic program, because greedy method, it's not that much. People do not ask you greedy method because the logic building and logic design in greedy method is a little bit simpler, and companies aren't much interested to know whether you can write greedy. They are more interested to know how your logic building process works specifically in dynamic programming, because this is something tricky, and they feel that any candidate who can figure out dynamic programming logic is better at writing algorithms. Okay, so the answer to the question that how to know if a problem is a dynamic programming or not, you should always search for this word optimization. I mean, optimize. They will ask you for finding minimum number of, max number of. The moment you find this, then 90% chances it is a dynamic or a greedy problem. If it is a competition, then in 90%, further 98% it is dynamic programming. Okay, so in coming sessions like tomorrow's, day after tomorrow's, we'll see like how to know whether it is a greedy or a dynamic later on. So we'll not discuss the greedy at this stage. Okay, so any optimization problems you find it is sure shot almost 90% cases it is always a dynamic programming. Now the dynamic programming method, this method primarily involves the following steps. Remember, now as you have said that you want to know the process of writing dynamic programming, first thing you'll identify dynamic programming. How do you identify? If it is minimization or maximization based on some concepts, it's a dynamic programming. Then you need to figure out how you can solve that problem. See, any dynamic problem, or I think I would say almost all dynamic programming problems, they always have a sub problem and a larger problem. Every dynamic programming problem has a smaller sub problem. So a larger problem cannot be solved in one go. A solution to the larger problem will be based on sub problems. So the second step in solving dynamic programming is to always find what is that smaller sub problem. If you can crack that sub problem, you will get the solution to larger problem. So the method usually involves the solving of dynamic programming method usually involves splitting that problem into smaller sub problems and solving that sub problems. And whenever you're solving that sub problems, the solution of sub problem has to be stored somewhere. Or when I say the solution to the sub problem has to be stored, it can be stored in a different data structure, or you can rely on the recursion stack. Sometimes I hope you know that when we call a recursion across the function call chain, each function call state is preserved. So whatever variables you have at any function stage, they are almost like they are being stored. So when you backtrack in that recursion call chain, you will always have access to that function's local variables. So the second step in this method involves solving the subproblems and storing the solutions of those subproblems. And when I say storing, what type of storage or what type of method or what type of approach you will use to store this data decides further coding logic of your solution. If you prefer to store it in a data structure, it might become something called as bottom-up or top-down. It depends upon that. So then once you find a solution to all sub-problems, the next step is to figure out how you will get a global solution by using the sub-problems. Remember, in dynamic programming, if let us say I have problem X and it has a 10 sub-problems. In dynamic programming, not all 10 sub-problem solution might lead to a global solution. So a 5 out of this 10 sub-problems may lead to solution of that. So in step 3, we need to know which among these sub-problems is important to find out solution to the global problem. So 3 steps. What are these 3 steps? First thing, breaking down the problem into smaller problems. Second, figuring out a strategy to store this solution to the sub-problems. And third is finding out the approach to combine solutions of a sub-problem so that it leads to the global solution. So we have 2 methods to combine solutions of a sub-problem. And these 2 methods also decide what would be your storage data structures to store solution to the sub-problems. So these two methods are top-down and bottom-up. So when I say top-down approach, it is nothing but it's a recursive way of solving the dynamic programming problem. And whenever you solve any dynamic programming solution by using recursion, it has to in all 100% cases implement memoization. Memoization is nothing but storing the result of function call so that next time when you need that function call again, you won't be calling it again or you won't be executing it again. So we will see some samples of top-down memoization as well. Then the second approach is bottom-up. Here it is nothing but it is here it is what we usually write as iterative solution. Remember, any dynamic problem, if it can be solved by using top-down, it can be solved by using bottom-up as well. Any dynamic programming problem, if it can be solved by using bottom-up, it can be solved by using top-down. Now, when to use top-down and when to use bottom-up, it is purely the developer choice. So as long as you can build a logic, you can always write that logic either in a recursive format or in an iterative format. So all students who usually spend time like whether should I use recursion or should I use bottom up, there is a one suggestion for you. Do not spend time on choosing what approach. Choose any approach, you will get that. Your thinking and your logic should be more based on step 1 and step 2, like breaking the optimization problem and how to store. And you have to perfect your method of using top down or bottom up. Remember, every dynamic programming problem can be solved by using either of this. So based on your practice and based on your ability to quickly write a code to structure that into bottom up table or top down approach, you would prefer to use that method. Remember, it is not that like by using top down you will get solution quickly. No, both solutions are exactly same. It depends upon the developer choices. I have seen developers who hate recursion, who find difficulty in writing recursive solutions. Sometimes it's not that intuitive. Recursion is not that intuitive. Like logic quickly doesn't clear to your mind. You have to trace some calls and then you get to know what exactly is happening. So for such students, I would recommend you to practice every problem by using bottom up so that you won't be in a fear of using recursion. At the same time, there are few developers who are recursive logics and understanding the recursion intuition, these steps of writing recursion intuition. So those can always stick to top-down recursive approach. So it is up to you. There is no standard anything that you have to always use this, you have to use this, or for an X problem, bottom is best, top-down is worst. No, it is wrong. It is purely the developer choice. Based on your practice, what suits to your logic design capabilities, you will always prefer to either top-down or bottom-up. So we will see some approaches either using top-down and bottom-up, or I'll share links to few of my earlier recorded videos where I think your knapsack and some of your standard textbook problems have been solved by using both the problems. So that will help you understand what is the logic in building these problems. Okay. So now, since we have seen what exactly is dynamic programming, we will now look at how to solve a dynamic programming. Remember, to solve a dynamic program, there is something called as approach. There is some a coined approach called as fast approach. So when we say fast approach, it is based on 4-step process. So it involves the first step. What is the first step? For any programming problem, specifically if it is dynamic or optimization problems, do not directly jump to write the code. It will inhibit the process of building the logic. The first and very important approach, what you have to do is take a pen, pencil, whatever you have, but try to just roughly design the logic on that. For example, if I ask you to write a Fibonacci code, instead of directly writing Fibonacci code and all that, with a small pen or pencil or whatever you are comfortable. I'm not saying when you say pen pencil approach, it doesn't mean you have to always take offline, you have to write. The intention here is to first think about the logic in your brain. Your logic should be first clear in your brain. Then the logic will be converted into program. I have seen students, what they do is they do not build the logic. What they do is they keep on writing the code as and when logic builds. So for example, if I want to write a code for calculating Fibonacci number. So instead of thinking logic, if I say like, okay, let us first declare variables, you will write a declare variables. And you have decided that you will use recursion. So what you will do, then you will write a definition Fibo and you will write just a function template. Then you will think that how should the recursion work? Then you will write you will say fib of n is equal to fib of n minus 1, and then you will write that. Then you will think of what would be the base case. Base case, I mean, you will be thinking of how to terminate this equation. Then you write a code. If you do this approach of programming for dynamic, it will never lead to a solution. Why? You will waste your time in writing the code, and you are also wasting your time in building a logic which is incomplete. So if you do this approach, rarely it leads to a solution. And this approach will work only if you are very expert. When you're programming for 5 years, 7 years, 10 years, you are a coder, you are a top coder, you participate in Google Summer of Code, a top level programmer. Only those people can have this special skill of writing code and thinking logic at the same time. So I would very specifically advise you not to do that. What I advise is, first design the logic. It could be pen paper, or it could be in your mind. Think of like, okay, I will declare the variable, then I write the function code, then this would be a base case, then I will check for these two conditions, and then first build a rough logic in your mind and then start writing the code. Okay. So for any dynamic programming problem, the first thing is roughly get the solution. Okay. After roughly getting the solution, what you will do? Second, analyze the solution obtained. And when I say that whatever the solution which you obtain to a problem, remember, it could be brute force logic as well. It could be non-dynamic programming approach as well. But just have the solution. Now, once you have built the solution, analyze that solution. When you are analyzing that solution, I'm sure definitely you will find a scope where you will see there are some sub problems. You will see that some part of your logic is repeating every time. Then you will find out, okay, this small logic is repeating. If I take the example of Fibonacci series, you will see that there is always the addition of two variables. Okay, then you will see, okay, this is how the addition is happening. This addition process is something which is iterated. So that's a sub problem. Okay, so rough solution, analyze the solution, then find a subproblem identification. Even if in a step one, if you obtain a brute force solution, you will definitely find a subproblem. You will find some part of that logic which always keeps on repeating. Then once you identify subproblem, you have to turn the process 1, 2, 3 into a recursive iterative solution. This is a rough and a time-tested method to find a solution to a dynamic program. Remember, this is something very tricky approach. So there isn't any standard method which will always give you a solution to. No, there is not. But whatever the approach which we discussed, which we call it as fast approach, this is something most developers found useful in getting a solution to the dynamic programming problem. What's the first thing? First, do a rough logic. Second, analyze the solution. Third, identify the subproblem and turn the process of 1, 2, 3 into recursive or iterative solution. Okay. So before I move ahead, any quick questions? You can reply me in yes, no, so that I can move ahead. Okay, so let me move ahead. Okay, so we have seen this 4 approach. Let us look into a very detailed approach. Okay, so that 4 steps can be further split into a 7 stepwise approach. First step, recognize the dynamic programming problem. How do you recognize the dynamic programming problem? As I discussed, that problem will definitely have something called as minimization or maximization based on few conditions. Like they will say, how can X person cross the bridge in minimum steps? How can some condition can be met with the maximum profit? Or how can the loss be minimized? Such things. The moment you find that, it is 100% or sure it is a dynamic programming. Once you do that, what's the second thing? Identify the problem variables. I mean, the moment you find this is a dynamic programming, apply the fast approach, give a rough solution, analyze the solution, identify the subproblem. After identifying the subproblem, express the global solution in terms of subproblem solution. After that, identify the base cases. So once you identify recursion or iterative cases, you have to always find out this iteration or this recursion has to stop at a particular point. What is that particular point? You have to identify that. And as long as it is a recursion, it is always easier to find the, the base case. But for iterative solutions, whenever you're using the bottom-up approach, you have to be particularly careful because what are the data structure which you use, it depends upon the data structure. So for iterative solution, you have to find out where effectively your loops or iterative loop should terminate. So that would be clear. Like when we look at problem by problem, that would be more clear. Then in the end, once you do that, decide whether to implement it iteratively or recursively. This is what I said in step 5. Based on your comfort, whether you are more comfortable in writing that logic in a recursive format or iteratively, choose the approach. So there is no any hard rule that this problem has to be solved by top down, this problem has to be solved on bottom up. If both are interchangeable, I mean, if you have solution this, it can be converted into that. There are very rare problems where sometimes the recursive code, if you want to convert into iterative, the readability of a code and the ability to write the code might be very complex. It might become very complex. Sometimes the code looks with the smaller lines neat in a recursion, but if you want to convert into iterative, the process might become complex. There are few problems, very complex, but rarely happens. But be assured of that. Then if you want to use recursive, then you have to make sure that you use memoization. And memoization will always see the problem with dynamic programming is its time complexity is reduced at the cost of space complexity. I mean, more space is occupied here, and that additional space which your algorithm requires, that helps in reducing the time required for this problem solution. So space, you have to take care of that, and space is not a much constrained resource, so that's fine, and that's something what dynamic programming problem demands. That's fine. No, it's not an issue. Then determine the time complexity. Remember, even if you write a dynamic programming solution, the time complexity of your approach has to be in a proper, it has to be something acceptable and feasible. Most dynamic programming solutions, they have O of n, n square, n log n or n cube. But remember, you shouldn't have any dynamic programming problem solution in exponential order, O of 2 to the power of n. Then in that case, it would be better you write a brute force approach instead of dynamic programming problem. Okay. And this step 7 is something which is very important when you appear for competitive programming. Like sometimes it happens that even if you're sure that you wrote a dynamic programming solution, still some of your test cases do not pass. Like they say timeout or time limit exceeded. Then in that case, it might be a case that your dynamic programming problem is not an optimized one. You might need a further optimization, like it might be an O of n cube and you need to bring it into O of n square or of n or n log n. And this process is where here your proper choice of data structure helps you. So in data structures, we have a lot of various data structures which help me in going for this optimized approach, O of n, n square and n cube. Okay, so this 7 stepwise process. Okay, so once we solve this, like the question comes to, how do I build my skill in doing that? The only way to do this is to practice it well. Remember, the dynamic programming is something you have to practice here. And one thing, when I say practice, let me tell you something about practicing. Like people say that you have to practice, you will become better. It's okay for some skill fields. The practice might help you in doing that, but the problems which involves logic building or problem solving, whenever you are practicing, see the I would say instead of practicing, I would say it should be a smart practicing. So instead of solving 100 problems, you can gain the same skill by just solving 10 problems as well. But those 10 problems have to be very carefully chosen, they have to be very carefully analyzed. So as I said that, do not directly jump to solving solution. You still say I have solved 100 dynamic programming solution, I can solve any. No, it doesn't happen. There are some ways to practice dynamic programming problems. So what exactly it is, let me discuss. Now, whenever you go for dynamic programming problems, this link has a lot of dynamic programming problems. Now, there are hundreds of 500, 1000, 2000, hundreds of dynamic programming problems. A best way to develop a skill in dynamic programming problem is that there are some patterns in dynamic programming. Like for example, string problems. There is something called as string editing. There are something called as selection selection paradigm problems. I mean, in that category, you will get this knapsack type problems. Uh, this knapsack is such a problem. Based on that, we have even almost 10 to 15 further problems, which are nothing but which are the knapsack problem modified into different terminologies. So we call them as dynamic programming patterns. Likewise, one more pattern is shortest path patterns. So based on this shortest path, there are a lot of different dynamic programming problems. So a true way to practice dynamic programming problems is to find out. See, now we have said all this. I'll tell you what an experienced developer does. An experienced coder, when he looks at a dynamic programming problem, he would definitely identify this dynamic programming problem. An experienced coder, what he will do instead of finding solution and analyzing and building and all that, what he will do is he will first try to find out if this problem fits into any of the patterns which he has practiced. If you identify that a specific problem belongs to a specific pattern of dynamic programming problem, your solution is almost ready. Because these problems, based on these patterns, they have a standard common structure. The moment you identify a pattern, writing code is almost simple. Sometimes people almost do by heart that, okay, this pattern, I will apply this logic structure, you will get a solution. So this is something you will develop this after practicing some problems based on those patterns. This is something a higher order trick. Okay. So initially, I want you to practice the problems based on identifying sub problem and doing that. And once you feel a little comfortable in that, or then you can move to directly finding the pattern in that, apply the logic relevant to that dynamic programming problem pattern. So what are those patterns? Some of these patterns are min max, like min and max path to reach to a target. Like here you will find some grid based problems. They will say that on a grid you are at this position, find out the minimum number of moves or maximum number of profit you will get to reach to one end of that grid. So this is as one pattern. Under this pattern we have a lot of problems. The moment you find out this problem comes under this pattern, you can directly apply that logic. Then the second is distinct ways. Like I'll tell you some of the sample of. They will say that in how many minimum distinct ways a person can reach to a X spot on that grid or a X spot on that city. For example, I think you will always find that a person can reach to the top of a building by using two steps on the stair or three steps or one step at a time. And they will ask you what are the maximum number of distinct ways a person can go to top floor by using the stairs. That falls under this pattern. And the second is merging intervals. These are the problems where it is based on something called as subsets. Like they will ask you to identify two subsets whose sum is equal or two subsets whose product is equal. So it's based on that, like something called as window based methods. Then we have a strings. For example, those who are practicing dynamic, you might have encountered a problem. They'll say that there is a string, and they'll give you some steps. They'll say step one, you can replace a character by X character. You can delete a character, or they say that you can add a character, and they will say a string in one form by using minimum number of steps. You have to convert into form two. Those are string based dynamic problems, and we call it a string editing distance. It's a very standard problem in dynamic programming. We call it a string editing problem. So these are also dynamic programming pattern. Then we have decision making. This decision making are they one of the famous problem on the decision making is your knapsack. So all problems which are similar to your knapsack, like 0, 1, like you have to choose or not, shop at the specific spot or not, leave it, delete it. So these are called a decision making. The best example of problem under this pattern is knapsack. Then we have almost 17, 18 of patterns, but out of that, uh, almost 7 or 8 patterns are enough. Like that's enough. Like most problems, 80% problems, they always revolve around these top 8 patterns. So if you want to go through what are those more patterns, what are the problems there are, how to solve that, you click on this. So it would lead you to this page here. This is what I have already compiled, and I think I've been sharing it with the students. So these are the problems. Minimum path to reach a target. How to solve? What are similar problems under this pattern? Distinct ways. How a statement in this will like some all possible ways to reach the current states. So you will have climbing states, unique paths to medium, number of dice rolls with a target sum medium. So, and some similar problems which are based on this pattern, the pattern of distinct ways. So these have been compiled. So what I advise you is at least go through these problems. You will always find a solution to these problems. So when you go through these solutions, you will understand that how this all these problems, they are fundamentally based on one common pattern of solving these problems. And this is what is the trick to solve most dynamic programming problems. So see, this would definitely take a time, and this is not something which you can do in just 1 day, 2 day. It takes some time, and I generally advise you to do it right from the starting of third year. I'm not sure how many students have gone through this, or for how many students got this link. But this link I've been doing it for last 3 to 4 years. So see, you want to practice this dynamic programming. The best and easiest way to develop skill in this is to follow this pattern in this. Remember, these are something which are time tested. Though I have compiled it based on numerous forums, numerous student experiences from top developers on Code Forces and other sites, based on the ACM ICPC contest, based on all those. So make sure that you go through this. So this is a string based, like you have string 1, string 2, return some results. And it's also clear that this pattern will always have O of n square. So longest common subsequence, palindromic substrings medium, edit distance, subsequences, longest. So go through these problems. These are something, they are all based on lead code, and these are hyperlinks. You click on that, it will take you to that problem. Try to identify this pattern. What are the pattern in solutions of these all problems? You can identify problem in this, you can try to solve this. Check the solution, try to solve this. That's how you will practice them. So don't just blindly sit and practice 20, 30 dynamic programming. No, that will not develop a skill. This is where you will, this approach is what which helps you a lot in this. So coming back to this, okay, so what we will do is, we will quickly go for a small problem. I think most of you have already solved this problem, but still I will go through this. and we'll see how to solve this. This is something a very introductory dynamic programming problem. Like, so this is dynamic programming because I can tell you by looking at this. Okay, so by looking at this, I can able to tell. But remember, this is something. It doesn't talk about the minimization or maximization, but it satisfies all the properties of dynamic programming. Like we have sub problems. A global solution is based on sub problems, and once you solved one sub problem, you shouldn't solve that sub problem again. Like once you solve that sub problem, you have to store the result, and this result is something which you need to use after and after whenever you that sub problem is encountered again. So I hope you can see the problem. uh, just I'll give you a few seconds to go through this problem, and then I'll discuss this problem. Just take a 30 seconds to read this problem. I think it should be visible now. Take just 30 seconds, and we will try to discuss the solution, and we'll also try to solve this problem as well. And which language you are comfortable in? Okay, so we'll use Python to write a code so this problem. Okay, so I hope you have read the problem. So what this is asking, what this code is actually, what this problem is asking you. So this other, whatever the additional that Saumika, Vinay and all that, that is something which is added. Like you have to be careful in interpreting that. But if you look at this, what they're asking you is, they're giving you a string. Because what is most important in this? They're giving you a string, and they're setting that its starting index is 1. Remember, it's very important. Like I hope this was discussed with you earlier in other sessions by other faculty. There's an approach to always solve these problems. Like there are some few checklists. Like whenever you go for competitive programming, what is main thing to do in this? Sometimes this problem might be one page long, a very big problem. So in that case, what are the tricks? Like how do you quickly, without wasting time, you can find out what exactly has to be done? There are some tips and tricks. I hope that were discussed in day 1 and day 2. So I'll not go into that. So here, so what is more important is I have a string. So the input to my programming is a string, and output is something I need to print a string, that is show. Okay, so string s, and its starting index is 1. Fine. So the moment they say starting index is 1, I have to be extra careful about index. Like I need to see in Python, all my data structures index start with 0. So I have to take a special care about 0 and 1. This is done to deliberately increase likelihood of student committing a mistake. a poor developer will always commit a mistake whenever there is a change in index. So this requires careful attention to wherever you are making indexes. Then what they are saying, string S consists of characters from 1 to 9. So what they are saying is string S will always contain characters from 1 to 9. Like it might be a big number which will contain numbers from 1 to 9. Remember, if you look at this here carefully, there is 0 is not a character in this. That is something we have noted down. So we are trying to build a logic here. Then what I'm saying that as she is very intelligent that I'm not interested in, okay, then what it is to, okay. So here the second part of problem starts. So input is string S. The string S will contain digits from 1 to 9. 0 is not included. And string is always indexed as 1. Then after that, it asks Vinay to count the number of even numbered characters. So from a string of digits from 1 to 9, I need to count how many of these digits are even numbered digits, like 2, 4, 6, 8 are the even digits. For every index I, and I is less than or equal to 1 and length of this. So when I have a string, for each index I of that string S, I need to calculate, result should be calculated from I at the end of string. For index I, the result should be calculated from I to the end of the string. So if I am at index 2, then 2 to end of that string. What I need to calculate? I need to calculate a count of even numbered characters. As Vinay doesn't know this, okay. So we'll see the sample input and output. So this is the string, and it contains digits from 1 to 9. And what they are asking you is, for every index, you have to print the number of even characters. What you have to print? You have to print in the number of even numbered characters from that index to end of that string. Okay, so they have given explanation. So given string S 5746 for index 1. So index 1 means this 5. So this 5, the number of even numbers from 5 to end of the string. From 5 to end of the string is 7. Is it case? So this is 0, 5 is odd, 7 is odd, 1, 4 is even, 6 is even, 2, 3, 4, 5, 6, 7. Okay. So that's why they have 7 here. So for index 1, I have to print the count of even numbered digits from the starting till the end of that. Okay, if I am at here, I think still it becomes 7. If I am here at this, it still becomes 7. Okay, so fine. Okay, 1 and 1. So here if I am at this 7, it is 1. Okay, if I am at 6, it is 1. So I think since it is I is less than or equal to, then even the current index number is also counted in that stuff. Okay, so now what do you think? Like, okay, so without thinking of what I would say is, I am not asked you to write a logic, but can you tell me what would be the best possible complexity of the algorithm for the logic of the solution? Can you think and tell? So don't tell me your logic, but instead of discussing the logic, tell me the complexity of your logic. I mean, does it require n square or n log n? What do you think? Can you discuss in this? Some say n and then n. Okay. So this is Akash says this is not a dynamic programming problem. So as I said, now it's up to the developer to say whether it is dynamic programming or not. As I said, it still satisfies all the checklists a dynamic programming problem has to have. So n log n and okay, I think it is, yes, it is n. So usually if you work on this, the solution to this problem will be O of n. So this might not be a perfect dynamic problem, not a templated dynamic problem, but yes, the pattern of that solving subproblems and adding it to that, it directly comes to what do I say? It directly reflects this as a dynamic programming problem. So can anyone tell me the logic how to solve? So okay, so we have figured out it is n. So let us figure out a solution to this. So when we are talking about this problem, the first approach, see, I know how to check whether it is what do I say? I know how to check whether it is even or not, even or not, and even or not. Fine. So at every index, what I need to do is I need to check. I need to scan all remaining characters from that index to end, and I need to just count number of even characters in that. So this looks like a simple logic, but if you do on this simple logic, like remember, if you're building your logic by based on this explanation, sometimes this explanation affects our thinking process. If you build on this, the logic which you will be building based on this explanation, like you are at index 1, you will calculate all counts and you will have 7. You are at 2, you will calculate all this. You are at 3, you will calculate all this. You are at 4, you will calculate all this. This logic will be O of n squared, right? So this problem can be solved in even optimal way. Remember, if you're starting here and you're doing that, remember, if you see, look at the pattern, what I'm saying, that you are at this index 1, you are scanning all this, right? Then you are at second, you are scanning all remaining string. You are at third, you are scanning all. Remember, if you look at this scanning process, there is something which you're doing redundant. Every time you're scanning a part of array which is already scanned earlier. There was a part of array when you're scanning it for index 1, this was all already scanned, and you know the answer for this, how many even numbers you are there in that. So when you're scanning for the third one, you shouldn't do the same operation of scanning that subpart of array multiple times. So this redundant operation increases the complexity. So there are various ways to solve that. So one of the very, you might call it as intuitive, but what we can do is we can start scanning this array in reverse order. So what we can do is, first I'll try to get the even numbered strings from the last index. Then if I increase one more count here, then it should be whether it is even or odd plus whatever the value you had in the earlier skill. So instead of starting from first index, you will start building this problem from smallest subproblem onward, right? What is the smallest subproblem? When I have only string at index last index. If you see here, I'm starting at index 1, I need to do the end. But if I start at end position itself, it's only smallest problem. Then the second problem is start at one index lesser than the last index. Then your problem is this 2. Here in when your problem is just the size of 2, it is nothing but the solution of the last problem plus this. And when you take third one, it is nothing but the solution of this 7, 6 and whatever you find for this 4. 4 is even, so 1 plus the solution for 7, 6. Likewise, when you encounter this problem, it is nothing but solution of this 6 plus the solution of 4, 7, 6. That's how you will start building that. Okay, so let us do one thing. Just let me know, have you understood this logic of finding this string, solving this problem from scanning it from the end of the string? If you might ask me, like, why end of this string? The end of this string is because I am in search of the smallest problem possible in this problem. When is the smallest problem possible? When I'm at the end, like where if I only have one string at one location, then this is the smallest one. Second, one character added to its front. Third, one character added to it. So this has a pattern of growing this problem right from looking at smaller subproblems. So this is how we are building based on subproblems. The moment you reach to the start index, it gives you solution to the entire problem. I've understood this logic. So we can write a solution for this. Okay, so we have, I think already some students have discussed this. Okay, count, check events, store it in set of and do. Okay, so let us write a solution in Python, right? So now when we are writing a solution in Python, see, now it is up to the skill of using Python code efficiently and how we can write and all that. Let us also discuss, like, what do you think? So this is logic. Let us also see how a logic is converted into a code. So when you're converting a logic into a code, it's important that you rely on some of the optimizations you get in Python. That's always helpful when you're writing a solution for a problem. So I think for this problem, instead of okay, so let me do one thing. I'll have my own way of writing this, and then in the end we will discuss what exactly I can do this. Okay, what's the first thing I need to do? The first thing is something I need to read the input. So I'll call, let me call input string is equal to, I'm taking the input. Okay, so after taking input, since this problem asks me to check even or not, so okay, so tell me what you would recommend. I want to just see your logic. How should I check whether the character is even or not? Now it is something I'm asking you regarding Python. I have a string. I need to check each character of this string. Like I have a character. I don't even have an integer. Remember, I am reading a string. What do you recommend? How do you recommend that I check for even and odd? There are two ways. One, convert that character into integer, divide by 2, check for that remainder and quotient, then decide that even or odd. Or do you think is there any smart way to do check whether it is even or odd? Any smart way to do this? ASCII might not. What do you think, ASCII? How do you think ASCII can help? Okay, you can do that. Like I think you want to say that you will check whether 2, 4, 6, 8 these as a characters ASCII value. Yes, I think that might work. But in Python, what I'll do is, since I know this, I have only 4 possible event digits. What I will do is I will set the what I would say is I will set the event characters. So what I'll do is I will say event characters is equal to, I'll define this list so that I can use what do I say? I can use the Python's list searching capability 2, 4, 6, and 8. Okay, so now every time I get a character from the string, I need to just say whether this character is in this 4 or not, whether this character is in this 4 or not. It's a constant time complexity. So every time I get a one character from string, I'll check if that character in even characters, then it's an even. If it is not, then it's not. Right? Okay. So now what I'll do is, since I have to print that, I will maintain even counts. So this will act as a list where I'll store for each index. So this one, I am using it to get this output. So for every index, as and when I keep on getting this, I'll store this 1, 2, 3, 3, 4, and all this inside this one. Even counts. Okay. I think then I think I need to take length. So I will say input length, input str length. So you can do that as well, but it's not. Input str. So I have calculated the input length. Okay. So now what I'll do is, first thing what I'll check is, now I can check for all this. what do you think that I need to do is, okay, so what we can do is we can first set. Now, if I see what is that, see, now it is important that I understand what is the minimum length of string I would get. So the minimum length of string I see is 1. So I need to have that logic. So what I'll do is I'll initially set a standard value for the last. So I'm sure that I will always have 1-digit string as an input. At least 1 will be there. So I'm sure based on this constraint that I will not get a string of 0 length, right? Based on this constraint, I'm sure that I will not get a string of 0 length. So the minimum I can get is 1 string. So I will just set a value for the last character first. So the first thing is I'll check if the last character in this input string is even or not. If it is even or not, then I'll just append 1 or 0 to this one, right? Okay. So what I'll do is if input str string. So what I can do is last character of this -1. If this last character in the input string is in even characters, means what I'm doing is the last character in this, I'm checking if this is inside this set of 4 numbers. If it is in the set of 4 numbers, it means it is even, and I need to add it to the even counts. So even counts is a less, so I'll do an append operation. Remember, I'm doing an append operation at 1. Now, all those who are good in Python, appending an element to the end of the list is always O of 1 operation. So I'm damn sure here I'm not doing something O of n operation, right? So appending to the end of that list is O of 1, and it isn't a compute intensive. So you can always use that. If this character, the last character, is not in this set of even characters, I think I need to append 0. Okay, so this block has taken care of the last character first. Now, whatever I need to do it, I need to keep on building solution based on whatever I have added for. So from here onwards, I can put an iteration. So starting at this index, till the index becomes 0, I need to keep on repeating a logic build on earlier solution, right? So now let me, just to be clear about the index and all that, let me say input. What would be this string? This would be, I think, I hope this should be -2. Yes. Now I'll write a while loop. While I, what will the condition? I greater than or equal to 0. You have to check, like now you have to check. So I'll almost get this exact same code block inside this. So I need to check here if instead of input string str1, this would be I. If it is inside that, then events count. See, if you are at this position, let us suppose you are at this position. If it is even, what do you need to do? What should I do? Instead of appending directly 1, what should I do? I should add 1 to the earlier one, right? So whatever it is at one location after that, I need to add this. So the append would be based on even counts of. You need to calculate the index. It is a little tricky from back end. So what you need is the length, one location add length minus I minus 2. So see, if you, whatever it is that, what this does is it gives you the earlier location. So if I am at 4, if I is at this location, this expression or whatever I'm doing here, that gives you index of the earlier locations, like what count you had. For example, what I'm doing is I am at this location. I want this 2. What was the count of even numbers at one index ahead of this? This will be added to this if this is even. For example, let me come back to this position. Like, so 4, the 4 plus 1. So I am trying to access this location which I have already calculated from here. So in order to access one location back, I am using this one. I minus 2. Minus 2, yes. Minus 2 minus I will almost give you the same solution. We'll see if the test case fails, then we'll come back and debug that. But if it is not, remember, if it is even is not, then what I need to do? The current character is not even, then I need to just carry forward whatever the previous sum was, right? So what the previous sum is? This, it would be plus 1. The previous sum will be as it is. Okay. Then once you are done, since your loop to decrement I is equal to I minus 1, decrement that. This is what you are decrementing the loop. And once you are out of this loop, you need to get this. So to print, I'll let me initialize some blank string. I'm not doing some optimized thing here. So you can, let's see if I get time limit exceeded, then I'll go and I'll do that. I need to just concatenate. Remember, I have calculated all things here. The only thing remaining is whatever array I have in even counts in this. This I need to print the output, and what they're asking, it is to be space separated. Space separated integers, the result of index. So I'll construct that. So I'm not going for any optimization. I think you can later optimize it. We'll optimize it later if it fails few test cases. From end of that string, 2 minus 1. I hope you know this is a loop to traverse in reverse order in Python. So to print is equal to print. Just to not to mess with code readability, I'm just adding this. But remember, I think you can use join operation to quickly do a fast string concatenation operation as well. And but I leave that to you to do how quickly you can do this join operation. And in the one, you have to print it. And just to be sure that I'm not printing any trailing or leading spaces, I'll call trim method here. It is strip to print dot strip. Okay, let me save it. Okay. So, okay. Let me see that. Okay, what do you think? Akash Pushe has written something. D is equal to here. I think Akash Pushe has written some logic. Let me see. Def count. I written then let's say and D of key count. Print count at the end function length. Print count. I think even that code will also work. So you use a dictionary, right? Okay. So I think in my code, I am using 3 extra comparison. If you're using dictionary, then you are getting it perfectly O of 1. So here I am getting O of, let's say I'm doing 4 comparisons. So whenever here, I think those who have seen the solution used by Akash Kushi, they'll get that. So what he has taken is, he has taken a dictionary here and he's searching it on a key. What I am doing is, I am just searching within that. Why I am doing this? Because I am sure that this is not a major comparison operation. It has to always do 4 numbers, means at the worst, 3 comparisons, it should be able to find this. So yeah, even that logic will work, like dictionary logic will also work. So let me save and let me run this. Compile and test. Oof, what are you saying? Okay. Semicolon. Colon, not semicolon. it says if input I where I will this. Okay. Did I miss somewhere the semicolons everywhere? No. Okay, sample test cases have passed. Let me click submit. Okay, so you see almost 8 test cases and 8 in all test cases have passed. So result is accepted and the time seconds is 0.08. So I think Akash, if you have solved this, can you tell me what was the value for your time? Is it less than 0.8 or around that? Okay, so yeah, you try it and you see if this count will be 0.8 or less than that. So you can see that the complexity is O of n. It is not n square, but we are only using O of n. You can try, an interested student can try to write O of n square, like starting from boot force and see. I think definitely it would wait somewhere, like it will definitely it will not pass few test cases. Okay, so as I said, like this is something very basic introductory dynamic programming, as you have said. The trick here is to keep on building upon solution of earlier problem. So the main trick in dynamic programming is you have to keep using solution which you already calculated and keep on building on top of that. Okay. So I think since this you have done this, let me see. There is one more problem. Let me see how many of students can get it. I think it might not be. I think I have given this for you for a test. So I just want to see like how many are very good in data structure. Because remember, for to be good in algorithms, you have to be good in data structure. It's a prerequisite. Okay, I think you might have gone through this problem. Have you gone through this problem? Check if n and its double exist. Okay, okay. Okay, so can you tell me what is the complexity of this? What is the ideal complexity of this problem? What do you think the ideal? The current complexity of the code which you see, like the code which I wrote here, the current complexity of this is O of n log n. But do you think do we have a better approach? This problem, remember why I'm talking about this problem is, if you're good at data structure, you will find the best solution to this. Anyone able to find out? Whatever I wrote here, it is O of n log n. But remember, the time complexity of the best solution to this problem is O of n. Did any student figure out that? Or do you think, like, can anyone give me a rough hint? Or why I'm discussing this problem is, before I go with further dynamic and greedy problems, I want to see how good you are in data structures. So I want to see how many of you are able to guess O of n solution to this. Yes, it's hash map. Yeah, I think Ajay Fade got the right hint. By using hash based data structure, you can get the solution of this problem in O of n. So we will see the code. Like if someone of you, if you want to try, you can try. If not, that whenever we get some extra time, we'll try to write a solution to this this code in Python. So in Python, if you want to have a hash map, what would you use? Ajay, can you tell me? You said it's a hash map, fine. But in Python, I want a hash map like data structure. What would dictionary? Yes. Dictionary would do, but the code might become a bit tricky because you have to keep on adding keys, you have to keep on deleting keys. Yes. You have to take something called as default dictionary. In Python, we have something called as default dictionary. You have to use that would be a better data structure than the we have something called as dictionary and we have something called as default dictionary. You can check that. Try the code. We'll see like what we can get. Okay. So now coming back to this dynamic programming problem and that, what would you do? Remember, the best thing is to start exploring this. Start exploring this. Every problem in this and everyone, if you really want to develop, and I'm not saying that you will go through this. I'm not doing it like coaching institutes or the training organization. They'll say that 21 days perfect in Java, 40 days bag offer with I'm not like Whitehead Junior. Remember, this takes time. This takes time. You have to be you have to be patient in that. So any student who want to follow this, who want to practice it, who want to go through that, and who might need some of guidance from me, I am fine. Like you can always approach me on Telegram or WhatsApp, or you can create a group of students who will practice on this. Then you can add me there, invite me there. So whenever you are practicing, you have some questions, you have some explanation like why it is this, why not something, any change in this, you can do that. So I'll be open to help you there in that group. Okay, so go through that, and this is what I've already shared practice problems. So I think you should be able to further go for this. And if you want a very detailed approach of dynamic, tabulation, theoretical, and practice, I recommend you to go through the recorded lectures, which I think I'm not sure for. I think 6 months back, I guess 6 months back, I engaged design and analysis of algorithms. There were a few problems like knapsack, and I don't recall what problems we have discussed there, but few dynamic programming problems we have discussed, gradient dynamic. Especially, I think the sum of sub problem, longest common subsequence problems, and some dynamic problems we have seen that. So there we have discussed both bottom up and top down approach, detailed step by step approach. So anyone who is interested to go through that hour long videos at his own speed and by skipping all that, he can go through that. I'll share that link to that playlist. It's on YouTube, but go through the, I personally feel they will definitely help you in understanding the bottom up and top down approach. You want this link? Let me share here in chat window itself. Okay, so I think that's it for this today's session. Before I end this, can you just tell me whether you found it useful or something? This was redundant, or this was new, or this was something which helped you, or anything? So, in conclusion, how would you develop this skill? Smart practice, not hard practice, smart practice. Look at the patterns and go through that pattern, find out solution. And remember, it will take time. I'm not saying this is something you'll develop in one day, right? So, any chess players here? Those students who play chess? So the students who play chess, they might understand that in chess we cannot become perfect in one day. There are some standard set of moves in chess. So every time you look for that move, like the moment you in a chess, I think the professional chess players will understand this. The moment you encounter a specific move,
the next sequence is always fixed. You know that, okay, once the player commits this move, you know how to tackle it, how to lead it to the checkmate. So dynamic programming is similar to that. Like you always look for pattern and pattern. The moment the pattern hits, the code is all implied. You can quickly type and you can get it done. Okay, so I'll not take much of your time. You can keep on practicing. I think the problems which I've given you for test, I think they are from lead code. Go through that. And remember, don't look it to these problems as a test score and that. Look at it as a chance to learn. Okay. So I think I'm done from my side. And if you do not have any questions, we can end this session.